Hey everyone. Yeah, thanks for having me. Thanks, Heather, for setting this up. So today I'll be talking about building conversational applications. It's not going to be a theoretical talk. We're just going to talk about some primitives and some concepts, and then I'll do some cool demos because everyone likes demos. And yeah, if you've already built a lot of AI applications, this is not going to be new to you. If you haven't, I hope this is going to be a great starting point and it's going to excite you to go home and start building some cool stuff. So before we start, a bit about me. I'm Rakan Nimer. I'm a product engineer at heart. I've been writing code and building solutions since I discovered programming on my school calculator. After university, I founded a startup and I grew it for 8 years. Then after that, I sold my soul and joined Amazon. Yeah, I spent 4 years in AWS, and then after that, now I'm in Amazon ads. So yeah, that's it about me. So yeah, what we'll be covering, it's not going to be a long presentation, so hopefully you won't be bored. I'm going to start by quickly covering what I mean by a conversational app and what's the difference with a more classical app. I'm going to talk about foundational concepts and advanced concepts that you're going to need to know to build these kind of applications. Then I'm going to do a quick overview of the tool landscape, and then two very cool demos, I hope, and then some lessons learned and things to watch out for as you go to production with AI applications. So yeah, what you can get out of this talk. So I hope by the end of this, you're going to be like, oh, that's super easy to build AI applications. I can get started. I don't need like a math degree or anything. It's going to give you some starting points on what to research, and hopefully the demo will give you some inspiration and ideas on some things you can build. So what is a conversational application? It's an application where the user talks to it, and natural language is the main interface that users use to interact with your backend and data store. It's a bit different because you have to maintain state across the whole conversation. And then past behavior, so a message you send 10 message before can influence outcomes 10 message through the conversation. So it's a bit more convoluted. So the classical app goes like this. Almost every single app is going to follow this pattern. It's very predictable. You load the page, some events happens, you validate input, you talk to a server, and then server fetches data from an API or a DB and returns it. There are three failing points that are clear. So you have either a validation error, an API DB error, or a render error after you get the application and you're rendering it in the UI. So it's very predictable. You know exactly what you're getting. You know where to watch out for, and what kind of retry logic and all of that that you should be handling. With conversational applications, it's gonna hit the talk that's coming up next. It looks a bit like spaghetti, right? Because a bunch of things can happen. So you can you input some text and then your text might not be clear. So the LLM is going to tell you, hey, I don't understand what you're saying. Please clarify. Then you answer, and then it needs some information that's not in the training data. It needs to figure out what time it is, or if it has any like reservations that are available. So it's going to call a tool that you give it, and then the tool can fail in obscure and interesting ways, and then you need to handle that. And then after this happens, you might move to a different state, and now the LLM has a different job, which is like to answer your question and doesn't have to do a tool call. So there's a lot of states that it can be in, and you need to track that in a simple way because otherwise you end up with a unmaintainable mess. So some differences with classical, it's deterministic. You know exactly what's going to happen for a given input, what the output is going to be. Conversational, it's non-deterministic. Change the model, change the word in the prompt, or even same model, same prompt can have different results. So static UI flows versus dynamic conversation. So you can have, when you're building a UI, you know exactly what are the touch points of the user and what are the flows that they do. Whereas in dynamic conversation, you can be three messages in and the user now wants to ask a different question that's unrelated to what you're asking them. You need to figure out, okay, now I have to answer this and I need to call a different LLM and figure out a bunch of things. Yeah, in classical, you have very tight control. You know exactly what's happening. You can control every single flow that user goes through. Versus the other, it's more probabilistic. Even testing LLMs is quite tricky. So your integration tests are not like, okay, confirm that the data that I received from the server is the data that I see on screen. Is my answer good enough? And it's hard to answer, right? Like, is my answer, there's no like if condition that you can do. There are some mechanisms for that. And then when you build conversational apps, UI is an afterthought. So you build your backend, and then you can talk to it via email, via WhatsApp, via Signal, via Slack, Discord. Doesn't matter. UI is not your primary thing. It's the backend is what you care about, and UI you can build your own. You can use anything. It doesn't matter. So let's start with some very foundational concepts. So system prompts. This is what you tell your LLM to tell it how it should behave and what it should answer. So this is like your basic instructions that tell it how it should behave. So some examples, like you're a law specialist tasked with answering questions about law, always start by mentioning that you are not a lawyer. So this will tell it that, hey, I should be answering as if I was a lawyer. And then a bunch of other things like you're an expert front-end engineer. And there's a whole theory about how you should be writing and formatting your prompts. There are different architectures for prompts. We're not going to cover prompt engineering, but it's something definitely interesting to look into if you're interested in that. Second part is text generation. So this is the output of the LLM is meant for a human to consume. So when a human needs to consume your text, your output, it's what we call text generation. So the input is going to be the system prompt that we said before, and a list of messages of the conversation. And you're telling the LLM, hey, give me the next message based on this history and this system prompt. So I'm going to show some code just to make it more interesting. Here I'm using the AI SDK that Vercel built. It's an open source library. It's pretty cool. Some people prefer LangChain. I like this. I don't mind LangChain as well, but both are interesting. So yeah, this is working code. Like you can just copy paste this and it will work. So here what we're doing is we're fetching the user profile from a database. Then we're feeding it to an LLM and telling it, hey, take this JSON and convert it to a nice human readable string that describes this user. And it can be arbitrary. So this is like what we call summarization task. And then you can also have a system prompt and a message history. So here you're telling it this is who you are as a person, as an LLM, and those are the messages, the history of messages. Figure out what the next message from you should be. So this is meant for human consumption, but LLM magic output is not just for humans. So it becomes quite interesting when you use the LLM output for consumption by machines. So to do that, it's good to have a schema of what the output should be. So you tell the LLM, hey, this is my problem. Always generate a JSON that looks like this. And then I'm going to feed this JSON to other parts of my system. And it's going to do some stuff like, I'll show you a couple of examples, like, is this spam? What is the user saying? Data pipelines, like, is this a good lead or is this a bad lead? So some examples, same as before, it's the exact same. You give it a model, a prompt. So here we're getting some sales lead from a database. And then we're asking it, is this a legit lead or is this a spam? And then the output that I want from you is what we have in the schema object here. So you should return is spam boolean, and you should give me a confidence score of how much you're confident that this is actually spam. So before LLMs, you used to have to train like models to do these kind of things. It was pretty annoying. You needed a lot of data. You need to do a lot of legwork. Now, all of the most classification problems are solved by LLM with just a system prompt. And asking it for, hey, give me a Boolean and a percentage score. Another example is, so this is a food delivery agent. So here you're getting as input some human readable string. So I want a large pizza, and I'll do a demo of this to showcase more. But then we map whatever the user says to an object that our database or our API can understand. So in this case, it's an array of pizzas. Each pizza has a topping, which is an enum, and then a size, which is also an enum. So I know for sure that whatever the user is sending me, I'm going to get as an output this JSON object that I can put in my DB or send to another microservice or whatever I want. Okay, so it gets a bit more advanced. So as you saw, it's just a function call, right? So the nice thing with functions in code is that you can compose them to build complex stuff. So a simple function is going to do the magic, but then you can compose these things together to have more complicated output. So you can take the output of one LLM, feed it into another LLM, then continue that until you have like a totally different output. And with that, you can build agents, workflows, data pipelines. Sky's the limit. So yeah, this is usually where people you would mention like LangChain. We'll talk about LangGraph shortly, but yeah, you don't really need LangChain. You can just use the AI SDK as well to do this, to do some chaining. I'll show a couple of examples of that. So here's an example, and I'm going to show you a code base. Like in the demo, I'm going to show you how this translates to an actual application. So suppose you want to build an application or a widget generator. So you want the user to give you some text, and you want to build them a widget or an application that maps this text to actual working code. So one way to do it would be like you chat with ChatGPT, like build me an app that does this, and then it would be just one LLM call that prints out a React component or whatever. But your results are not going to be great if you do that. It's better to focus, like have very narrow agents. So here I split the problem similar as to how we would do it at a company. So you would have like user requirements, then you'd feed it to a PM. The PM would think about it, generate some product requirements, send them over to the designer. Designer would take these product requirements, generate a wireframe. Then we would go to the backend developer and tell them, hey, can you write me some SQL queries that help me fulfill these requirements? Then we take all of this and we send it to the front end dev. And we tell it, hey, create a React component. This is the SQL query. This is the expected output. This is the schema of the wireframe. Can you generate some code? So yeah, by the end of this, simple 5 word like show me my top revenue in 2024 is mapped to a production ready widget that you can start using. And I'll show a couple of examples of that. Then tool calling, this is critical. You can't rely, like you're gonna need your LLM to do some real world action. So it's either like writing into a database or reading from an API or database. Like if you ask it, what's the weather today? It has no way of knowing that from its training data. So it's gonna need a way to say, okay, I don't have that in my training data, but I have a way to get that. And this is what a tool is. Just think of it as a function that an LLM can call, and then it will take the output of that function and use it to respond to you. So in this case, like this is the classical example. I'll show you a more interesting tool example shortly. So you ask it like, what's the weather in Tokyo? No way it can answer that from its training. So it looks like, oh, I actually have a tool called weather, and it has an instruction saying use this when you want the weather. So maybe I should use this. And it gives it a parameter Tokyo that it extracts from your text. It understands that Tokyo is the parameter that it should pass. Tool responds back some JSON object. This is the current weather. Then it takes the output of the tool and synthesizes a response. So yeah, some example like search flights, fetch weather, store in DB, generate chart. And this is a example code also to showcase the simplicity. It's just a function. If you look at execute, this is what happens. This is how you're telling it, okay, run the tool. And you're telling it whenever you want to send this tool, the LLM should send the location as a string. So this is all you need to build this flow that we built. So next up is semantic search. This is critical to understand as you're building like RAG applications, and yeah, and understanding how LLMs work. I think it's critical. So the idea is you can transform words into vectors of meaning. And then once you have those vectors, you can find similarity. So instead of doing like if I say what's the weather like and I want to find similar thing, I'm not going to do a text search, right? Because there could be a lot of things that mean this, but others formulated in a different way. So do we have a way to transform words into vectors? And then we store these vectors in a database. And then you can query by similarity, by using cosine similarity for things that are close to it. So an example of this, so yeah, you start by taking it, whatever your read word data is, a wiki or your URLs, your code commits, whatever you want. You transform it into vectors, you store it in a vector database, and then when the user prompts your LLM, it can search the vector database and give you relevant records that are related to what you're saying. So for example, a query, a feel-good user might have a match of main man wins $1 million from $25 lottery ticket. Like this kind of similarity search is impossible without this. So yeah, this is critical. And then building on top of this is RAG, so retrieval augmented generation. You're going to hear this a lot. Most chatbots use this. So it's mostly for chat with your docs application. So suppose you have a company wiki that has thousands of pages, and you want to build a chatbot that allows you to ask questions about a shit ton of data. There's no way you're going to put all of that in the system prompt and then say, hey, from this data, what do you think this? So it's going to cost you a lot. It doesn't make sense. So the idea is, as we said before, you would take all of your company data, store it in a vector database. Then the user asks like, hey, what is the HR policy for return to office? And then it's going to find all of the text that's similar to this, put it in the response, and then summarize it and give you an answer. So the answers are no longer like from its training data. It's fetching data on the fly and then summarizing it and extracting the right information to answer you. Yeah, so as you can imagine, like I've probably seen a lot of like chat with your docs applications. If your company has a lot of wikis, you probably have, there's Amazon Q where you can point it to some of your documentation and it will do that for you. And there's a lot of RAG as a service. So you might not even need that, but it's interesting to know. Last, so agents. So this is where it's no longer a function call, it's a system. And there's a bunch of architectures for agents that we're not going to cover, but there's a bunch of ways where you build agents. But as a high level, it's almost always the same thing. You place an LM in a control loop. So you ask it to do something, then you observe the environment, and then you act. Okay, so for example, let's take a look at like cursor, how it works. So you tell it, hey, update this file. It will observe, it will look at all your files, figure out which ones are relevant. Then it's going to set up a plan. So, okay, I need to change this file, this file, this file. Then it acts on the plan. So it edits your file 1, file 2, file 3. Then it needs to observe again to make sure that the task is done. So it runs some linter, it runs anything that, or some test or whatever to make sure that the input, that what it did is correct. And if it's not correct, it keeps iterating the loop until it has a good result that it's happy with, and then it stops. So at a high level, a lot of agents are going to work this way. Just think about it as a control loop. Observe, plan, act, I think is a good way of thinking about it. And yeah, as I said, there's a bunch of architectures on how these can be built. But yeah, at a high level, this is what it is. Okay, now the most important part, and I think it's not talked about enough, which is testing LLMs. So it's pretty annoying. Like if you thought like debugging a web application is hard, yeah, talking to an LLM for hours to figure out that it starts failing after 20 messages is its own version of hell. So you better have automated all of this, and then for example, if you change one word in the system prompt, all of your test cases now can break. And it might be like you're not even thinking about this, just changing one word. You want to make sure that all of your previous tests are still working. So it's a very important when you're building an application, write down all of your, like what your prompts are, conversations, 10, 20, 30 messages, run them every time you change anything. Otherwise, you're in for a world of pain. So they call that evals. There's a bunch of frameworks that do evals. OpenAI has a version, Cloudflare has a version, but you probably don't need these. If you have some basic software engineering principles, you can build your own evals, right? It's just an array of messages and some expectations. So this is an example of an eval architecture. So you would have your LLM. And then the tricky thing with testing LLM, as I said before, is that it's not easy to say, did it answer right? Or like, is the answer correct or not? It's not a string comparison. So the most common thing is first you need the metric, which is like cost and some basic stuff like response length, some things you can chart. But the more interesting one is LLM as a judge. So you would have an LLM decide if the answer is correct, and it's LLMs all the way down, right? So you have like LLM, you talk to an LLM, it responds to you. You have an LLM that takes this output and says, okay, this is a good response, and it will put a percentage of how good the response is, and then you look at these outputs, and you can evaluate, hey, am I doing a good job? Is there a regression? Did updating from a GPT 4.0 nano to 4.1 nano to to O3 really helped me in terms of, you can see like latency has increased, but my results are way better. So you need to do these evaluations because there's no clear answer. You need to test a bunch of stuff, look at results, and decide what works for you. So yeah, to summarize some of the concepts we covered. So generating text, this is anything that the LLM will spit out for humans. Generating objects, anything that it will spit out for machines. So machines will take the output and do some stuff with it, either render some UI or update some database or call some stuff. Chaining for agents, multi-turn planners. Tool calling, almost everything you built is going to have some tool calling ability. RAG is, you're going to hear that all the time. Then agents, obviously, for more complex workflows where it's not just a one-shot thing. You need a loop, and it keeps going until it actually does a problem. So if you notice now, the new models that are released, what they say is no longer just like, hey, does it answer correctly on the first try? It's about, it can spend 7 minutes on a problem. Like that's pretty impressive, right? Like, so it keeps going and iterating for 7 minutes, and it doesn't go into a hallucination loop. And this is how you evaluate new models, because like one shot is, there's a limit on how good it can be in one shot, but stick it in a control loop and you have something way more powerful. And then evals, we talked about this. So yeah, I just wanted to show you this. This is, I found this from Callion KS. I didn't make this chart. It's not, it doesn't cover everything. By the time I finish this presentation, there's going to be 10 new things. So yeah, there's a bunch of these. Don't be paralyzed by how many things there are. You don't need most of these. You're good with just knowing, okay, that you have LLMs. They can be public, you can be open or closed weights. And then frameworks, I mean, get a feel of the problem before you start using the solution. Otherwise, you're not going to know what framework to pick or what problem you're trying to solve. So the way I did it is I didn't use anything and I tried to build everything myself. And now I have a better understanding of, hey, what are these problems? What are these frameworks solving for me? So yeah, that's, yeah, as I said, new tools are going to come out. And then, yeah, good software engineering principles are all you need, along with the Magic API, which is an LLM. And then, yeah, state machine graphs. Once you have this, you can build anything. Okay, now the fun stuff. Let's do some demos. So let me get out. So there's no auth for this. So if you want to use this, I have a token limit of $5. Knock yourself out. After that, it's going to stop working. So yeah, this is an interesting project that I built for this talk. So what the problem is, suppose you have a CSV, a giant CSV, and you want to visualize the data inside of it. You want to build charts, build components, build a web application based on the CSV. You could send it to ChatGPT and it will write some Python and show you some chart. But then you're showing all of your data to ChatGPT, which is not always what you want to do. So the problem this solves is it does this offline. So it doesn't, all your data stays on the browser. But what we do is, let me show you them and then we'll discuss them. So let's go to IMDb top 100. So here I took the CSV, converted it to a SQLite database, and then I have a WASM compiled SQLite running on the browser. And here it's showing me a sample of the data. So nothing here is going to the server. This is all on the browser. So this is my data. And now I can start chatting with it. And I can tell it, hey, show me a bar chart of top 10 movies and add a filter at the top that allows me to change genres. And yeah, now what it's going to do is it sends a message to the backend and it starts a workflow. So first thing it does is it's going to map this to a SQLite query. And then it's going to start writing some code. So it goes to the backend agent. It tells it, hey, generate a query that helps me solve this. So as you can see here, it's just getting the by IMDb ratings. And then it generates some UI code. I gave it some good instructions on how it should generate UI code. And I'm streaming it back to the browser. And then we have this. So this is from my actual CSV that I just uploaded. And it's rendering this data, so I can switch genres, and it updates automatically, and this is just from a sentence. And then you can make it arbitrarily complex. You can ask it to do more and more stuff, and it's going to do it. It's so the trick about how it does it offline without sending the data to some API. Oh, let me show you one more example, actually. So yeah, this is one example. Let's do another. So I was going to do a Robinhood thing, but then I don't want to expose my finances to everyone. So but you could. I'm not going to be reading the data, so feel free. It's not uploaded anyway. So this is a happiness index, and it shows how happy different regions are. And then you have economy, freedom, trust. So let's tell it, yeah, show me top regions by happiness, and then also show me a bar for, let's say, economy. So I'm trying to understand if is more money equal more happiness. Basically, like is when you have a good economy, does it mean it translates to happiness? So yeah, assume this goes on, and then it's going to generate this. I swear this is like didn't do anything. Just so I asked it this similar question, and it generated this. So it's showing me the blue is the happiness and the green is the average economy. And then you can change the metrics. So you see, for example, is family actually what drives happiness, or is it economy? Most likely it's economy. Money makes you happy. Uh, yeah, so yeah, this is all generated. This is two prompts, right? This used to take like an engineer a day to do, and now it's two prompts. Yeah, so
would you be able to show us what was actually sent to the LLM?
Yeah, so
in addition to the prompt that you gave?
Yeah. So actually, I could show you. Yeah, you just open. So what I'm sending is the schema of the SQLite. Once you update the CSV, I have some JavaScript TypeScript that's running, takes the CSV, infers the types, then builds a SQLite table. So I send the LLM, hey, here's the schema of my data. Here's my system prompt. So I'm telling it, hey, when you want to fetch data, so let me show you an example here. So here it's using a use SQLite query hook, which I gave it. I don't want it to think about this stuff. So I give it some tools to use when it's generating code. And then it goes through this. So first step, it goes to the backend agent. It tells it, this is my schema. This is the user conversation. Generate a SQL query for me. Gives you a SQL query. Then you go to the second step. Here's my SQL query. Here's the response type that I expect from the SQL query. And then here's the user requirements. Write some code. And then you give it instructions on how to write code and which hooks to use. And you get,
yeah, I have a question. Is like, how do you do this without calling an API?
Yeah, so I am calling an API, but I'm not sending your data. I'm just sending the schema of your data.
Okay, yeah, but like at the end of the day, you do send, like you do call OpenAI.
Oh yeah, OpenAI or Anthropic, but it doesn't touch your data. Like if you have like some private stuff, I'm not sending that private stuff to the OpenAI.
Oh, I see.
I'm just saying, give me a SQL query that if you have this schema,
okay,
I could run it to get an answer to this response.
okay.
So all it knows about is the schema of your data, and then it can do. And this concept can apply for a lot of front-end stuff where you want text input filtering. Just structure your data as a SQLite instance, and then call your AI to create a query for you. And then on the front end, just run that query and visualize it. This extends to all of these use cases. So yeah, feel free to play around with this. There's no auth again. Don't do anything illegal, but you should be good otherwise. So that's demo one, and here's a diagram of how that works. I'm not going to spend too long, but let me just show you real quick. So yeah, as I said, the web client reads the CSV that you send it, maps it to a SQLite schema, then creates a SQLite database and inserts all the data from the CSV. Then it talks to the server, it sends it the SQL schema, the user message, and then the server is gonna, it's gonna call a tool. So if you notice, when I started, it created like a document, and then it started streaming code into this document. So how this is happening is the LLM has a tool called create doc and update doc. So it calls create doc, and create doc is where the magic happens. It does the LLM calls and then streams data back to the initial call. And then after the LLM finishes the create or update document, it takes the output, summarizes it, and sends to the user. So we have like a data stream from the create doc tool call, and we have a data stream from the text, which is from the initial call. Yeah, so second thing I want to show, and that's inspired by actually your demo, the Svelte state machine demo. So it's something similar. So let me show you. So this is my state machine. So here I want to build a pizza delivery agent. And I want users to be able to chat, order a pizza via SMS, email, terminal. So let me show you how that works. So this is my code base, and let me do it via terminal. I'm gonna zoom in. Just 1 sec. Let's take this. Okay, so I'm gonna start right now. As I said, when you're building AI application, doesn't matter what the UI is. So I'm gonna use a terminal for the chat interface. So let's do bb dev. Oh, sorry. npm run dev. Yeah. So here it is. So it starts with, hey, this is the delivery service. As you can see, it went to. You have to look at the right and the left at the same time. So it started with intro send, and now it's at intro receive. So it's waiting for a response. So I can tell it, hey, what time do you close? And then if you look at the right, it goes to answer service question, send, and answer. Okay, so it says, okay, close at 11 p.m. daily. I gave it some information. So now let's make it a bit tricky and ask it, hey, are you open now? But it's gonna figure it out. So let's see what it does. And the current time, so yes, we are open, and the current time is 6:50 a.m. So how did it do that? A tool call, right? So I have a tool call that says get time, and that returns the date object of the current time. Then the LLM called that, and based on that, compared, okay, 6:53 is less than 11, so I can answer. So now I'm an answer service question. Now I want to order. So I'll say, hey, send me a large pizza. So if you look here, it's going to go to the state for ask for order send, then ask for order receive. So it tells me, hey, okay, you've requested a large pizza. Let's see, let's tell it cheese pizza, thin crust. I'm not giving all the information. Let's start with that. So if you look here, it inferred the order. So similar to what I showed you in the demo where you can like generate object, I'm giving it the conversation. I'm telling it generate object that follows the schema of my order. So here it figured out the crust, thin, pizza, cheese, size, large. And then it also figured out, so in the control loop, I have the remaining field. And then now it figured out that the remaining field is what type of sauce you would like. So let's do barbecue. And then told me about, okay, your order has been confirmed. And yeah, now it's waiting for other questions about the service. I can ask it like, do you have desserts? And it's gonna answer, oh no, yeah, that's ignore that. Yeah. Okay, so we're almost done. Bear with me. So yeah, lessons learned, as I told you, create an integration test very early. This can get really tedious, really expensive, really painful. So do it. Don't, now with LLMs, there's no excuse. Just spend 10 minutes and do it. Choose the right model. You don't want to end up in like using a cannon to kill a fly. Like using small models will solve most of your problems unless you're generating very complex code. You should be good with a tiny model for almost all of your problems, unless you're doing something quite complex, which you're probably not. And then, yeah, just like functions and code, keep your LLMs organized. Don't have, so on the left is like what you would think you might want, like the application that I showed you, like example system prompt, where you tell it everything it should do in one giant prompt. LLMs now are not good enough to like just internalize all of this and figure out the right way to do all of these steps. So it ends up being a good idea to do similar like your code, let it do one thing and one thing really well, and then compose all of these together, and you have much better output than just one general LLM call. So instrument your tool calls. Tools can fail in all kinds of interesting ways. So if your tool fails and you don't have proper instrumentation, you're never going to know, and your customers are not going to know. They're just going to think you have bad software. because like it's gonna call a tool and then the tool fails, but the LLM is gonna be okay. I'll just hallucinate the answer. So have metrics, have alarms on your tool calls. Don't let them be this dark black hole that you hope works in production. And yeah, otherwise you're flying blind. And last is cost. So yeah, we're all used to right now, like we have infinite compute for applications. But for LLMs, it can get pretty bad very fast unless you're really monitoring, you're on top of what's happening to your applications. Again, yeah, scaling can bankrupt you if you're using O3 for everything and you don't have any monitoring on your costs, you're gonna have a bad time. Yeah, that's it. This is my LinkedIn if you want to add me. And yeah, any questions?
Is there any sort of thing that's like the equivalent of, say, parameterizing a SQL query for LLMs to make sure that you don't have, I guess, not a code injection, but a prompt injection, I guess?
Yeah, so prompt injection is pretty hard to solve, like, but I think it's better handled by the AI providers themselves. And then, yeah, your input, yeah, you're right. Input validation is pretty tricky in this case. But yeah, you can do the standard validation stuff. But yeah, that's a very tough problem, and that's a good question. Yeah, sorry. Oh yeah, go ahead.
You talked about like tool calls used in various scenarios. Maybe real briefly, like how does something like model context protocol fit into?
Can you say that again?
Model context protocol.
Oh, okay, yeah. So yeah, tool calls and MCPs are pretty similar. So it's basic. I haven't worked too much with MCPs, but looking at them, it's like basically having tools for your systems that you invoke. But yeah, I'm not the reference for that. I haven't dived very deep in MCPs yet. Yeah, go ahead.
When working with like TFI, do you have an cosine similarity? Have you seen like lowering the value or lowering the similarity score to be like beneficial at a certain range?
Yeah, that's a great question. So how do you decide what is the similarity that you accept? I think it's about trying, and like if you lower it too much, then you're gonna have a bad LLM. But the thing is, if you lower it too much and then your retrieved data is not helpful for the answer, so RAG is gonna get the retrieved data and then summarize the answer based on the data. So it's not, if it's not relevant, it's just not gonna use it. You see what I mean? But then the worry is that it will hallucinate. So you have to put some guardrails telling it, hey, only answer if you see the answer in the prompt. So yeah, it's a lot of it is trial and error and seeing what works.
So you were saying like you get the output of the LLM and well, in the prompt you say, I need a JSON, right? And you say a JSON schema. And that works good for like parse output for like ChatGPT 4. But there's like the majority of models don't accept like a predetermined schema. You can put it on the prompt, but since it's not deterministic, then you also risk that it's not going to output JSON. Like, how would you deal with that to maintain like a low latency? In case it doesn't.
Yeah. So the way I think about this problem is you tell it to. So suppose it doesn't support structured output. So you tell it, hey, this is always respond in this JSON. So just stick it in a small control loop wherever it gives you the output. Run a schema validation. Is it valid schema? If not, send it another message saying, hey, your schema is wrong. This is those are the errors. And then it will send you. So I know it's not ideal, but most models are going to support this. And anyway, you're going to need this control loop.
No, it's that I was working with that and we had that issue in which it was like real time, but the real time APIs don't support JSON schema. So we did exactly that you're saying, but it was a lot of latency.
It is.
It's like,
I mean, ideally you would stream something back to the user, or at least, but yeah, I agree, it's a tough problem. Yeah, go ahead.
I was just gonna say, I think it's the case that like the MCP in general aims to solve that problem. So you might in general using the formalized MCP.
Interesting. Okay. Cool. Okay. Thank you, guys.
Hopefully everybody's hungry. Okay. So this was inspired not just by Italian cuisine, but I've been noticing a ton of tomfoolery happening in the JavaScript ecosystem over the years, and You're going to see later in this presentation what specifically inspired this talk that really upset me. But I thought it would be fun to kind of talk about some fundamentals of like what makes good software design given your needs, your context. I'm not going to go into a ton of demos or like there's going to be a couple of code examples of like how terrible some things were, but it's really going to be a little bit more conceptual and hopefully fun. So about me, I've been a software engineer a long time. Thanks Tom for MySpace. And I've seen everything, starting from kind of vanilla JavaScript earlier on, and image maps and all the early web stuff, all the way to jQuery and then all the PHP type things, which is really where I got into. Wow, I can make money doing this with Magento and Joomla and Drupal, and all that stuff. And then of course we entered kind of this age of MVCs and CMSs and Ruby and Rails and Python from there, and now obviously modern stacks. Did a lot of startup stuff earlier on in my career, but now I work in money markets and treasury, which is the most exciting part of our industry. But there's a lot of exciting things to do as far as modernization in our financial industry. So there's a lot of exciting work to do there for something really important to our economy. This is my LinkedIn. If anybody would like to connect with me on the worst social media platform on the planet, we can talk about how we bring shareholder value. All right. So before we dive into code, let's talk about this really important quote from AI slop Will Smith, my favorite. Sometimes the most delicious shortcuts leave us with the biggest messes, right? As we all know, we all had a bad spaghetti dinner before. And so, honestly, this reminds me a lot of, kind of our current JavaScript ecosystem. So, we're seeing some trends that make me pretty upset. And sometimes I think, well, this is brilliant. And then my immediate other thought is, well, I've seen this before, right? So why pasta? Well, on one side, you have this beautiful spaghetti carbonara. It's purposeful, it's intentional. Every ingredient is in its place. It is just right. And the other side is spaghetti from my parents. This is no joke. Growing up, my parents, they were amazing people. I almost did not include this because I didn't know if they would watch this, and I remember they would not watch this. And so we're just going to, embarrass them a little bit. Instead of actual sauce growing up, they would use, I can't believe it's not butter, spray. They would like unscrew it and pour it on things as a sauce. And so they would be a huge fan of some of the frameworks we're going to see. But anyway, it's thrown together for speed and convenience. It was tough to say nutritious, but it was food, and so we were fed. What the heck is this, right? It is food, yes. So what started with the same basic ingredients ended up very different things, right? What's the difference? Well, the difference is that one was intentional and had some thought into it, and the other was speed and convenience. So that's the JavaScript ecosystem today. That's where we're at. There's a lot of high fashion. There's a lot of stuff, right? We've got sort of layered frameworks, and we've got a lot of interconnectedness, and I think we've lost our way a little bit in terms of what separation of concerns looks like. And so that's ultimately kind of the heart of this talk is like, what do we do about that, right? So the code parallel here is really important. This goes back to what I thought made a ton of sense earlier on in my career. I thought we had reached the pinnacle of what things should look like with single responsibility. Like I said, separation of concerns. It's easy to read, it's easy to understand. You can maintain it, which is huge. You can debug it, you can test it, right? Versus this mentality of just ship it, right? This is the aftermath of a series of decisions and other conditions we've ended up in, such as AI slop. Obviously, given the first talk, there's a lot of amazing use cases of AI, and there's a lot of ways to use it in our day. I use AI. There's a lot of ways to use some of these new tools, but in general, there's a lot of conditions that are leading us to start thinking about speed and convenience again over, I think, what makes good, clean architecture. So there's been a pendulum swing, right? We started with this nightmare, which was just sort of PHP and JavaScript and CSS and HTML everywhere in the same place, right? And we learned through very hard lessons that you needed to separate those concerns, right? And that's how we ended up with, patterns, whether you love them or hate them, with, MVCs, APIs, RESTful, BFFs, thinking about clean architecture. How do we actually build scalable architecture? And now we're mixing PHP into Vue components, guys. So you'll see where this came from. There's an article that inspired this in a talk. But the question that I have is, are we actually solving fundamentally new problems that require breaking old rules, or are we just sort of repeating mistakes with shinier tools, right? And so this was the inspiration for this talk. Now, look, this is not a, I'm not making fun of this guy, Aaron. He seems like a brilliant guy. I watched, unfortunately, the whole talk. And I've read a few articles on it. And I also want to make sure I'm not, I think Laravel is fine. I think PHP is fine. PHP is making a comeback. That's great, whatever. What I'm attacking here is not this individual, not his thing called Fusion, not Laravel, not PHP. What I'm going to ask some pointed questions about is if we should be putting PHP into Vue components and what that conceptually means for where we are. It is an interesting talk and an interesting thing to look into because, it's not, this is the only example that's not talking about that. But my first question, like I said, is brilliant. Are we solving new problems? Are we combining good existing technology for the best results? Is there something to this trend, right? These are very smart people. What's happening, right? Or is this Regretti Spaghetti? So I had to have some good spaghetti puns here for you guys. Spoiler alert, I think it's Regretti Spaghetti, but we'll talk about it. So on today's menu is the magic that Aaron described, he sold us, right? No routes, no controllers, just magic was the promise of his new Fusion library. And the way that Fusion works, I'm not going to go into a huge depth on this, but the way Fusion works is it uses something called inertia that's using Laravel. Of course, Laravel is PHP. And Vue, of course, is a JavaScript library. And so you've got these layers of communication that are happening with relative hidden complexity that allows you to not only have PHP in your Vue components, but you can communicate between your JavaScript and your PHP. So what Fusion gives you is writing PHP and JavaScript in the same file. Wow. Calling backend functions directly from the front end. Okay. Automatically syncing state between your backend and front end. And getting full end-to-end type safety. Just kidding, that's not easy. They're not yet. Anyway, it's not that each one of these are bad either on their own, right? There's definitely use cases for every single one of these points. And of course, we're seeing this elsewhere, right? This isn't just this extreme example of putting PHP in Vue components. You also have React server components now. Fine, there's use cases for this. It starts mixing server and client logic, but maybe there's places to use that. There's EV queries directly in the React components too, using gRPC style stuff. Okay. There's use client directives now that you have to put everywhere because of this. So that's cool. It's I don't know. I wanted to yell when I said this, but instead I just use all caps. So that I won't get upset. But it starts feeling a little bit back afterwards, right? We're entering this time of meta framework, and it's pushing for more back-end, front-end integration. And I understand why we've gotten here, which we'll talk about. But the word magic just really bothers me. And so imagine you're Aaron and you're in Congress and AOC's got some questions, right? Multiple languages in the same file is now an advantage. No, I don't know. Abstracting server client communications now improves dev experience. Okay, maybe. There's some short-term wins there, I guess. So the common thread here is write less code and ship faster. But all of this sort of blurs the traditional boundaries that we fought really hard to establish for really good reasons, right? And look, there's really good reasons why we got here. We're hungry for these solutions, whether it's because of API boilerplate fatigue. You know, how many of you have had to write the same CRUD boilerplate over and over and over again? There's a lot of back and front end context switching. You know, it's as soon as, like, I think even in the beginning of tonight, you know, it was suggested that people start thinking more full stack. Obviously, this is great. It starts growing us. It can even grow the JS community if we think like that. You know, I only hire full stack engineers at this point in my job. So this is exhausting when you have to constantly context switch, right? Time to market pressure. Of course, we've all felt this in real jobs. There's also in real jobs this difference that we need to think about. That's like dev productivity theater versus actual productivity, right? How much is this like visibility of the dance that you're productive versus what is actually productive, especially when you think about the long-term impacts of what you're creating, right? And so we'll talk about that a little bit. Anyway, we've ended up here for a reason. We're hungry for solutions because we've had a lot of legitimate pain, and there's a lot of allure in sort of the like, it just works magic. So what are my concerns, given my experience, for what it's worth? For large, real projects, what does performance look like at scale, right? If I need to continue scaling my products. What happens when there's high levels of customization that happen in the real world? How do I coordinate large teams of engineers to support whatever tomfuckery we've come up with? And then how do we maintain the long-term code quality of those tech decisions, right? And so for me, when I see the word magic, when I see it just works, no routes, no nothing, right? It just, to me, that's another word for hidden complexity. You'll end up rewriting all of that magic, inevitably, because you'll end up with performance concerns or scalability concerns or customization issues, and you'll end up with a lot of regret because you took those shortcuts earlier on. I think. And Shiloh does these things also. So the hidden ingredients here are the maintenance nightmare, right? Like you're dealing with debugging and testing and knowledge barriers, and you're dealing with scalability and indigestion. Sorry. Performance, separation, anxiety, like that, and we're going to dig into each one of these. So the maintenance nightmare, debugging complexity. Where does my error actually live, right? Is it in Vue? Is it in whatever these layers are? That's a great question, right? No matter how good your observability tools are, the more sophisticated and abstracted layers of complexity you've introduced with all these new shiny tools, the harder it can be to troubleshoot, especially let's say somebody on call who hasn't dealt with that particular code base yet. Now you're dealing with an issue, right? When something blows up. What are the testing challenges? How do you properly unit test a bunch of mixed concerns, right? It's possible. You can figure it out, but it's not fun. Here's a huge one for me, knowledge barriers. So imagine trying to explain the magic of Fusion to inertia, to Laravel, to PHP inside of your Vue.js components to a new team member, right? Let's say you just hired a few junior engineers and you've got to get them ramped up on the code base. You have to explain, let's say they've never even touched PHP before, right? You got to explain all these layers of complexity to them. Okay, well, there goes your like 3 weeks of onboarding to 3 months, right? And you scale that by organization. You're dealing with a bit of a mess there. But it's cool, you just throw that in the backseat. So scalability ingestion is another issue, right? And this is something we're dealing with currently in my job. We have to scale we went from like a very large but a single product organization to having to think about how do we develop platform teams and support teams, start thinking about being a multi-product organization, despite having this monolithic mess of a lot of interesting tech decisions. So there's performance implications there of how we scale that, what happens under load, especially when you start scaling horizontally. There's separation anxiety. What does it look like when you do have to split out services later and separate those concerns? Tech debt accumulation, right? So when you're under go-to-market pressure from an organization, you have to say, oh, sorry, we have to spend, the next 2 quarters on tech debt. before we can get there, suddenly those shortcuts don't seem like shortcuts, right? If you have to completely rewrite stuff, that compounding interest of those short-term decisions is going to catch up to you. So I can tell you, the person who decided to do Groovy on Rails 10 years ago at my company, I wish I knew that. What do we do about all this? We need a balanced diet. We need a recipe for success. I kind of threw this together in the Goldilocks principle, right? I was like, there's three bowls of spaghetti. I don't know. So the first one, you don't want to be too separated. You don't want to over-engineer things. It's important. You don't want to be too mixed. You don't end up with actual spaghetti, right? You need it to be just right. It's a contextual decision. This is kind of annoying and anticlimactic, right? It's like every time you want advice on what to do about something, the real answer is, well, what are your certain conditions in your certain organization with your particular teams and your particular needs, right? And that's sort of the best I can give you there. The right amount of abstraction depends on your specific situation. Well, we'll talk a little bit about that. So, are you prototyping or are you going to production? So, different rules for different places, obviously. Like, if you're starting a startup and you have to rapidly get prototypes out because you're starting to pitch, you want to get investment and all that, okay, cool. Maybe you want to do, Aaron's fusion thing with Laravel, and that's cool, whatever. What's your team size? Are you 2 engineers? You're going to be putting that prototype together? Or you like an organization of 200 people and some random 10 people you've never spoken to are going to have to suddenly support your application? That's going to make a big difference on who maintains that boilerplate, right? What's the project lifespan? Is this a 6-month thing before you actually build it? Is it a quick, maybe an event-specific application, and it's going to be dead in 6 months anyway, so you can do something cool? Or is it like a 5 or 10-year platform? That's going to hopefully influence your decision. And of course, what are your mitigation strategies? So, are you planning an exit strategy on that? Are you leaving any escape hatches open? Or how are you documenting the magic that you decide to use if you do decide to use it? Because there's nothing worse than trying to untangle magic with, some Confluence pages that you found a title for that might not be looking for, and then there's no content on it, and you're like, okay. So you want to make sure you're obviously documenting thoroughly too. So I call this the pasta test. Can I throw this against the wall as a stick, basically? So can I entangle this when requirements change? Which they will, always. Will I be able to separate those concerns when I'm forced to scale or pivot? Can my team digest this without me? If the magic is documented and learnable, maybe. But if it requires tribal knowledge, and a lot of the time it will, when you start making interesting decisions, that's not going to be fun for anybody. They won't be able to digest it later. And then, will this still be good tomorrow? Can you do it with leftovers? How will this perform and maintain with deadlines and bugs and real-world use? Like I said, dev on call 2 years from now. Are they going to be, if something pops up, how are they going to sort through this, right? So what's the final bite here? Innovation isn't about avoiding all antibiotics. I'm not being anti-innovation here. I'm not saying don't use new technologies, don't look into them. But you need to know, and this is true of whatever category, right? Not just tech. But like, if you're gonna break the rules as an artist, as an engineer, whatever, you have to know the fundamentals well enough to do that, so that you can be smart in how you break those rules, right? A lot of those rules exist for a reason, and so it depends on what you're trying to accomplish. If you're trying to accomplish like a big fuck you to people having to work after you, okay, but you don't always want to do that. So sometimes the best meal is the one you don't have to regret. We're already seeing the impacts of abstracting away too much, aren't we? I see this in interviews. If I've learned anything over the years, is to keep your technology simple, and especially as engineers, to keep what we're learning fundamental, right? So with the onset of AI slop and how it's threatening our industry and our livelihoods, learn as many of the fundamentals as you can. Don't learn just the top layer, cool talks about how to have PHP in your components. Like, learn the fundamentals of why that even works or why it wasn't done before. Even if you do choose to use some of those shiny new tools. This is an example from a blog post from last year, a year ago, 2 years ago, of somebody kind of describing the interview process with incoming engineers. And one thing that really stuck out to me is this candidate. He said he hadn't realized that the app was not a single page JavaScript application. You didn't know you didn't know that there were other options outside of SPAs. And I started seeing that too over the years. Like a lot of people have only learned React, but they haven't learned fundamentals. And so they're like, wait, how do I even, where do I even start? Like my first job, or one of my first jobs, you know, it was a massive like object-oriented like vanilla JavaScript thing that ended up being some mix of jQuery. And if I only knew React, I wouldn't have lasted at the job very long because there was no React yet. In fact, my job was to translate all of that in React. But I had to understand the fundamentals of object-oriented JavaScript to know what to start pulling out. So don't sort of just jump to the newer stuff. It was not a super long talk, but I wanted to just kind of give an earnest reminder in trying times with a lot of the, you know, there's a lot of chaos right now in terms of what the JavaScript ecosystem looks like. There's a lot to choose from. And what does it mean to like make good decisions in that time? So hopefully this is just a fun reminder that we should think about fundamentals and think about what our specific needs are and make contextually smart decisions. And don't do any that are going to upset me. Any questions?
So boilerplate good, actually?
Yes. Yeah, and of course there's always ways of writing good code that like in your own code base of starting to extract that, right? But at least understanding what boilerplate looks like is important. And a lot of our like most important systems rely on good boilerplate, right? Okay, so Corey says, am I just jaded or have you had experience where the prototype tech choices don't become default production choices? Yeah, I mean, I think that's okay though. Like, I think especially in, would it be nice if like things translated beautifully into like, here's what we prototyped with, and then here's how it like exactly starts translating into our final application. Especially, I think things like AI can actually help in this situation, right? Of like, here's my prototype, here's what works to, you know, as far as our concept, what does it start looking like for a scalable application, right? So I don't know if that's necessarily a bad thing, but I think it's definitely true.
What's your best Steelman argument for newer paradigms? Like, is there any particular concern, like experimentation, like feature flags was one that I see, it's just like possibly a lot easier with paradigms. It's something I used to fiddle about and like now I don't even worry about it.
Yeah, and I think this goes back to like my message about like not being anti-innovation, right? None of this is to say that innovation itself is an anti-pattern or that new paradigms are an anti-pattern. In fact, I think one of my underlying messages here is that some of the worst things I'm seeing are not new. They're like recycled, right? We're in this pendulum swing back to like, let's just have multiple languages in the same file and try to like abstract away how things should be communicating and reduce our visibility of how those work, right? And of course, like some new paradigms and technologies do reduce our maybe like our prior history and having to deal with that more directly and stressfully. Like obviously we're not writing things in you know, in binary or anything, but like you're not like putting punch cards in the computers, right? To some degree, like the more, you know, there's a lot of abstraction when you zoom out that like makes our jobs way easier. I'm not hiring engineers to write assembly most of the time, right? So yeah, I don't think all of it's bad. I think when it becomes a cyclical thing of like just retrying things that we know don't work and do cause issues on the road, maybe we don't have to try that yet, right?
So like I was like mostly backend engineer and I just focused like, you know, just Python and C and stuff like that. But lately the job market, at least in like what I'm interested in, has shifted a lot toward full stack. So that has made me shift towards JavaScript and then TypeScript, and then there's so many tools and the velocity is like really, really fast. And I don't want to do the kind of you know, noob stuff that you were saying about your candidates. So what's your advice of how to like pick up quickly, but not in a way that you end up missing the principles?
I will say, coming from a backend history, like your background is already kind of going to give you some of those fundamentals, right? Of like, what's an object, and like how do I write like clean code? How do I name things properly? How do I avoid like using too much resource, right? And a lot of those things, front end developers coming into a framework and just learning that framework, they also don't have any of those fundamentals, right? Because in the front end world, a lot of the time, from their perspective, they don't have to care about those things. So you already have a leg up there. I would say the front end specific concepts and fundamentals are important to know. So like, what is the DOM? How does a single threaded JavaScript application interact with that DOM? What's important to consider there? So taking some of that backend knowledge you have about resource competition and writing good clean code that has less complexity and all that, and like, what does that mean in the context of a browser? And that's really the big jump, right? Of like, what is the DOM, what are the objects on the page, and how is my code not interacting with that? And so when you jump into something like React, okay, well now you have to consider, with that fundamental knowledge, what is a React lifecycle, right? What is the lifecycle of those components? How is state being managed? Why should I care about that, right? If I'm just spinning up effects, is that a problem, right? How am I managing state properly and all that? So I think it's still, there are some fundamentals that obviously are unique to front end, but they're mainly unique to the context of like being on a client and thinking about how the browser works and what objects are visible on the page.
So I have a question it's not super serious, it's kind of nuanced, but you got me curiosity. So I'm doing a lot of work with Next.js right now.
Mm-hmm.
And you had a slide on there that I kind of laughed at, but I was like, wanted to see if you could expound on a little more where it said, it was like about the use client. You're like, I don't know what it said exactly.
Yeah. So use client, we're
use client, bro.
Right, this is already client, right? With things like Next, I use Next. I don't have a problem with Next. I think what starts stressing me out is like when I'm writing JavaScript clearly for front-end components, now I have to specify everywhere that I'm using client because of this like new paradigm of like almost being server side first for a front-end application. That's where I start having a conceptual issue, right? It upsets me a little bit.
It should be the other way. It should be a use server.
Right, like it should be the other way, right? And obviously you can't. Like there's ways to do that, but it's like when you start seeing that a lot, when I have like engineers submitting code with this a lot, and it's just like normal practice, and I'm like this isn't what it's supposed to be. It's like not supposed to be like this. So yeah, I mean, it is kind of a lighthearted joke. Like obviously this is the least serious infraction that I'm talking about, but it does start showing us this like meta framework direction we're going. And I think with the meta framework direction, however good it has also been, it's also creating some new challenges as far as like how far people take it. In fact, there's actually a quote from Aaron when he was talking about his whole PHP and Vue component thing, where he was like, what we did is we took what's it called here? I want to show this, like, okay. So he's like, this Fusion doesn't replace inertia. He's like, Fusion just takes inertia to like the craziest possible like extreme we could think of. And I was like, for who? Like, I was like, why? So it was like literally like how crazy can we make this? And I think the meta framework type direction is like giving people sort of like this, it's enabling them and like giving them the freedom to be like, how crazy can we get with like server-side rendering and front-end frameworks, right? So that's kind of where that comes from.
Just to clarify that, I really appreciate you putting that out there because I came into Next from React and I had the same feeling as well. Like, why do I say use client on the React tab? It was like totally busted.
Right.
And I'm like, I'm not gonna think about it because I got stuff to do right
now. Right. I mean, it just becomes, it becomes habit, but it's sort of it's another symptom of like where we're going, and I don't necessarily like some of the potential side effects in that direction. Oh, sorry.
Yeah. I actually have a question about that. So I'm not a front-end developer at all. But I know like traditionally, back in the day, I guess, most websites are like static pages, for example. And like whenever you need like not reactivity, but I guess sometimes dynamic you use like PHP or some form. So I guess where I'm trying to understand is like the actual, it seemed like there was an implication of like we want to be doing this compute on the client, right? So we don't want to be doing server-side rendering for some reason. But I feel like, I guess, if I were to look at this from like the grand scheme, I feel like this inertia, fusion, this whole meta framework ideas, this concept, like it's all kind of coming back to this issue that we're trying to do compute on the client side that really requires kind of, I guess, this barrier to be broken between the back end and the front end. And so I wonder, isn't the solution to move more towards the server-side rendering kind of direction? Or?
So I think the inspiration for this conundrum to begin with is actually that people wanted easier ways to work with server-side logic and reduce or extract the complexity between your front end and your back end, right? Fine, like we've always dealt with that, right? It kind of goes back to like these issues that I identified, right? Like why we got here, right? So, you have fatigue in sort of keeping that, that separation of your front end and back end, that decoupling of it. And so by recoupling it, they sort of like solved that problem, right? But they introduced the complexity that we had to begin with of like, well, now there's not necessarily a great direction in terms of where you put what, right? Now, of course, when you have this decoupling, you have to make good design decisions autonomously, right? You have to decide how much business logic am I putting in my front end? How much am I putting in my back end? But you also have the flexibility at some point to say, okay, my front end business logic for this specific thing is starting to get to a point where there's performance issues on the front end. Now I have a tech debt story to move that business logic to a backend component that does that for me, whatever service I'm probably already interacting with. And I tell you, that's a much easier lift as you need to make those decisions than making a decision earlier on that completely abstracts and confuses that relationship, right? So to answer your question, it exists because of the fatigue of that careful decoupling that we worked hard for. And it's now made it easier to recouple those things. And in many ways, I think that's going to lose people's fundamental understanding of like why front end and back end exist the way that they do.
Yeah, I guess the added question on that, mainly because I don't necessarily have context overall, but why do most of the why is the assumption to do the computation on the client side?
So I think that just comes from front end. Well, there's a few reasons. So one, let's say you're a front end engineer, you've been given a story to like list results on a page. Let's say you have a table of financial transactions. And now maybe you're pulling from 3 different endpoints the data you need because of the requirements you've been given. And now let's say you maybe have to do some accounting on that, right? To like have like some sort of value. Well, now you've ended up in a pickle, right? Because maybe that's fine for 100 of them or 1,000 of them. What happens when you have an admin-specific account that views all of them on the same page? Well, now you've run into a serious limitation from the client side. But because you were just a front-end engineer who was given a story with certain requirements and you made a business logic decision in your JavaScript, you didn't have the wherewithal. Maybe you even thought about it, but you're like, well, we can't really do that yet. And now we have a situation where your admin can't load page because Chrome gives a snap page, right? So that's one reason. Is like you have oftentimes you have dedicated front end and back end engineers. Sometimes you can have dedicated front end or back end teams that aren't even the same team, right? Depending on how your organization is structured. And so if there isn't enough planning ahead of time to recognize how that needs to scale, you could end up in that situation inadvertently. You also have a situation where laziness. Like, let's say you are a full stack engineer, but you don't want to open up a second PR in the backend service that has to get approved by other people, so you just add the business logic in the JavaScript on the front end component, and then you end up in that situation later when you deal with it. And so I think there's just this, like, let's say it's a smaller project, you start making those decisions. Again, it's like a laziness thing. Like if you're not developing a whole backend with all that business logic, and you really want your SDK to do a lot of the work, because that's where you're most comfortable, that's where you're putting a lot of your attention, it's easy to put as much logic in the client side as you can, because you're putting the most energy and attention into the SDK.
I think another big driver is traditional heavy server-side applications can feel a lot slower and less dynamic.
Yeah.
Every time you make an API call, you have that just the absolute minimum ping overhead of how long it takes to actually reach the server and come back, let alone the processing time on the server. Plus, you know, if the code's running in the client, it's free, right? Your server doesn't have to.
It's not compute.
Distributed, the price is right.
Yeah.
Fine with spas, yeah.
And if your engineers all have the newest MacBook, and their Chrome's operate, using tons of gig and whatever, like, okay, they might not even notice the issue.
Why is my phone 95 degrees?
Right. But let's say your client is using some old ThinkBook from JP Morgan Chase that only has, that's like locked down for the most part and is running all the spyware next to it. Like, they might have a much bigger issue, and so you won't even know until later on that you made a bad decision, right?
It seems like you mentioned earlier in the slide, like you have to know the rule before you can break it. I'm wondering if people like that in your picture here knew the rule before and now they're breaking it, but the issue you're seeing is that new developers are coming in, breaking the rule before they've learned it, and that's kind of the disconnect.
Yeah, I don't know Aaron personally. He's going to be really surprised when he sees this. But it's possible. Yeah, I think any of us who do have experience, and especially anybody managing other folks or like contributing to code bases or coming up with ideas, we have to be considerate of that, the responsibility that comes with that, of like, what's the end impact on new people coming in an industry that is rapidly changing, is like getting impacted hard by automation and executive, like, thinking that AI can replace all of us, right? Like, there's a lot of like compounding issues there. And if you have a bunch of engineers who are being sort of led astray by like these easy shortcuts, it could really be damaging, right? We have to think about that. Maybe you can keep it, if you really like that, you can keep it as an internal tool for yourself, right? Like, I don't know. I don't know what the right answer is there, but it's definitely, that is a bit of an interesting dynamic, right? Like, well, he knew the rules, and as an artist, he was like, I want PHP in my Duke components anyway. Yeah, I don't know. That's a good, we have to be considerate of our, downstream effects of what we do.
How do you balance using these newer directives like use server and use client versus like more traditional patterns? Like, React was invented to support kind of these kinds of like web app transitions where you're doing optimistic UI updates, loading states, you're waiting for server responses. This is, to your point, backwards. And saying that all of that is ironically not necessary, and we're going back to PHP, like, to your point. So like, how do you decide what becomes an optimistic client-side render feature versus something that you make someone wait for a network response for?
So a lot of that is, again, contextual, right? So like, let's say, in my position now as a manager, it's like, okay, well, I have to look at my resources. I have to look at like requirements or immediate issues we have to deal with. Like, maybe a page is having performance issues that's impacting some sort of business function. I don't have the backend engineers and people with the like tribal knowledge of certain backend services to go do something about that in like the right way, would maybe take longer. So, okay, I'm going to have a couple of my younger engineers who maybe have a little bit more free time. They're kind of they're not dealing with as important things on a daily basis. It can cost me a few engineering sprints of their time to do it sort of the like server-side rendered way in the next app, as opposed to like maybe a few other principal backend engineers that I have working on maybe something more important, right? So I'm juggling priorities, and I'm having to make sort of like sprint by sprint or PI decisions that might, in that context, impact what we end up doing, not necessarily it being the best solution, but maybe the best solution within those parameters. That's a very honest answer.
No, thank you. We can follow up. Do you think this drives home the point that we should talk about JavaScript being written on the server?
Yes, I think that's yeah. I think this talk ended up being a really good intro to us, like kind of not to influence any of your survey decisions, but it's important. I think it's affecting all of us. All right. Well, anybody, if you have any more questions for me, I'm on the internet, and so I'm also here once a month most of the time. So yeah, feel free to get in touch. Thanks, everybody.